All right, welcome to the webinar, Aircraft Exhaust System Defects Can Lead to Accidents. And this is the FAST team topic of the quarter for the fourth quarter of 2024. It's a very good topic for this critical safety-related aircraft system. Critical to owners, pilots, and mechanics. And my name is Gary Mitchum, and I'm the Airworthiness FAST Team Program Manager at San Antonio. So the topics that we are going to look at tonight we're going to look at some accident data, the basic problem, repairs, resources that are available, airworthiness directives, and the V-band joints, flanges and gasket failures, mufflers and heat exchangers, some brief look at inspections and pressure testing. Then we're going to look at some accident cases. And I've also gotten some pictures that were sent in to me from San Antonio District IAs. Now, this presentation was developed by the National FAST team, and it looks to me like they gathered data from 2011 to 2019. As always, I add to these approved presentations and bring in my own material, try to enhance them. So you can see that those are the 23 accidents and incidents involving GA exhaust system failures in that time frame. But I did my own NTSB Carroll search, and I used a keyword muffler, and I came up with 152 accidents that mention the muffler in the factual analysis. I'm assuming everybody can see the screen and hear. Somebody wants to put that in the chat, I would appreciate it. Just to make sure. Yep, okay, good, thank you, I appreciate that. Hate to go through this presentation and find out something wasn't working, so. So the problem is the FAA is concerned about GA exhaust system failures, and they continue to contribute to accidents and incidents. Muffler failures usually involve the internal baffles or external mounts or leaks. Exhaust system leaks can cause carbon monoxide poisoning, and exhaust system leaks and cracks can cause heat and fire. Very dangerous things to have occur when you're flying. We do have some resources available for exhaust system maintenance. We have an advisory circular, number 91-59A, and the JASC also came out with best practices guide for maintaining exhaust system V-band couplings and clamps. It's very good. Some of the pictures you'll see later come out of that guide. We also have good old advisory circular 43.13-1B, chapter 8, has exhaust systems. We also have a very good course on FAAsafety.gov. In fact, I took that this morning. It's ALC number 498, and they're listed in alphabetical order under our course tab. and it's a very good course. And I'm going to record this presentation, and it will be available on Skillful and socialflight.com. Now, if you want to find that best practices manual, I just typed that into the Google search window, and it was about the second item that came up. So it's a PDF and it's real easy to find. Now, there's been quite a few safety airworthiness information bulletins issued against exhaust and muffler or exhaust systems, I should say. According to that best practices manual, there's been 47 of them. So if you go to drs.faa.gov and on the left-hand side, pick under aircraft safety alerts, pick the SAIB tab. There'll be a drop down, kind of an option to do your search. And when I did that, I typed in exhausts and muffler. And then you click the apply button over on the right. And it initially came up with 58 results. And then you can click in the little box beside each SAIB and pick the ones you want, just by clicking the little box. And then if you click Save Selected Results List, in the upper right-hand corner, it will generate an Excel spreadsheet list of those. And those are all hyperlinked. You can click on them and go directly to the SAIB. So when I did that, this is the list I came up with. And I also did a little search for under airworthiness directives. I just typed in keyword, I typed in exhaust, click apply. And it came up with so many results, I did narrow it down in the subject block. I picked 63 items. Anything that said muffler or exhaust or V-band, anything like that, I selected it. And it, forget how many, just show what I typed in there. Came up with 113 ADs, and you can do the same thing. You can, if you click Save Results List without selecting any of them, it'll give you all 113 just by clicking that. And up in the upper right-hand corner, the little Excel download box will drop down and you can open the file. And that's what I did here and came up with a pretty good list of, that's not all of them, obviously, but just that's kind of what it looks like. Then you can click on the hyperlink and go directly to the AD. Now, according to the best practices guide for the exhaust systems that I showed you earlier, since 1975, there have been 20 ADs issued against muffler and exhaust systems. And there's the list of them they have in that manual. Now, 10 of those ADs are related to V-bands. So we're going to take a little time and look at these V-band failures. There's been numerous V-band failures that have caused accidents and fatalities. And we just saw that, I think there was 20 of them, 20 ADs issued related to V-bands. Here's an accident that was caused sudden unexplained loss of manifold pressure in flight. Anytime that happens, the pilot should assume that an exhaust failure may have occurred and put the airplane on the ground at the earliest possible moment. And if the aircraft is a twin, pilot should consider shutting down and securing the engine to minimize the threat of an in-flight fire. Exhaust system components require special attention because of the high temperature and vibration that causes metal fatigue. Here's shows where they've taken a V-band off of the joint here, and underneath you can see there's a crack underneath that joint. This has become the preferred connection for many exhaust or intake systems. And you'll see these clamps can be held with rivets or spot welds. And these are common areas of failure. So these are called two-piece when they have been spot welded or riveted. And then there are one-piece or single-piece V-band clamps as well. Basic theory of operation is the V-band applies a uniform and equal closing force around the entire circumference of the flange. Once tightened, the friction between the flanges and the V retainer actually reduces the load on the bolt and the clamp. Here's some failures that commonly occur. This one broke because of there were fractures near the spot weld location. Notice the safety wire is still attached. And they just blew up the area of failure there, so you can see it better. Need to have a lot of attention to detail to spot the defects. There's a crack on that tailpipe coupling in the upper left-hand corner. It's hard to see, but when they blow it up, you can see the crack. And there's in the center, that's one of the spot welds. And when you blow that up, you can see that crack. So it helps to use magnification when you're looking at these things. And sometimes they use a gasket. Just follow the manufacturer's instructions. Make sure you use a mirror to ensure correct alignment of the gasket and the clamp on the back side. Make sure everything's lined up. That's what this slide is telling us. The flanges must be aligned correctly before you tighten down the clamp. And make sure the V-band bolt doesn't bottom out before reaching the required torque. Now, if you have an exhaust system failure where, like on this one, there's a hole in this exhaust, and that would be blowing hot air right onto that V-band clamp. So that's likely to cause a problem or a failure of the V-band. And that QR code provides a very nice link to a YouTube video showing how to tighten down the V-clamp, how to torque it, seat it, and retorque it, tapping it with a rubber mallet while you're doing it. So if you want to take a picture of that QR code, and you can watch that video later. It's only a couple minutes long. It's pretty worthwhile. And then safety wire if needed, if it's called for by the manufacturer's document. There's the actual YouTube link. If you have any trouble with anything, just later on, you'll get the last slide is my email, so you can always send me an email and I'll get you whatever you need. Repairs, it is generally recommended that exhaust stacks, mufflers, tailpipes, and so forth be replaced with new or reconditioned components by a qualified repair station rather than being repaired or welded. Really requires special jigs, tools, and welding skills to make a proper repair. And they're stainless steel, so I think it's a little different welding techniques and equipment. Moving on to muffler and heat exchangers. Failures in the heat exchanger surface can allow exhaust gases to escape directly into the cabin heat system and cause carbon monoxide poisoning. Can also allow hot gases to enter the air induction system, causing the engine to overheat. And you want to remove that heat shroud to do a proper inspection. Mufflers and baffles, want to check closely for defects. You can see the one in the top right, it's got some damage. And then you can see the baffles inside the muffler, pretty well shot on that one. Exhaust systems with a turbocharger. Now you have these exhaust systems operate under a much greater pressure and higher temperature. So extra precautions need to be taken in exhaust system care and maintenance. Because if you have high pressure and high temperature, it's basically a blowtorch. Joints and welds are more susceptible to cracks, so you want to pay particular attention to those areas. Slip joints or ball joints or welds. It's a lot of times where the crack will initiate. You can do some testing with a shop vac, and that AC does have information on performing it, but the gist of it is you'll use the outflow or the blow side of the shop vac and then just use soapy water to check for leaks. If you'll type your questions in the Q&A or the chat, if I don't get a chance to answer them during the presentation, I will definitely send you an email answer. If I take questions during the presentation, this approximately 1 hour presentation will end up being 2 or 3 hours. So I normally don't do that. But I will get those answers for you later. So here's an example at a repair station that has the capability of testing and repairing exhaust systems. Top right, they've welded up this system and they're putting a plug in there. It's kind of like the rubber plug that you use in your boat. They put that in there and then they're applying pressure. They've got the exhaust in a water tank. And you can see the bubbles here. So this one didn't pass. So they have to go back and repair that. You also want to look for soot and discoloration because these are signs of leakage. And here you can see these flanges where when you see that charcoal or soot path, you know that's a leak. And on the right picture, that slip joint, you can see the discoloration there. So that's another indication. Make sure you use the right hardware from the manufacturer. Don't substitute steel for brass, for example. They use the material that they want to be used in there by design. So remember, these systems operate under intense heat and vibration. So you want to make sure you use the right hardware. Use high intensity light and a nice mirror, telescoping with the hinge. And to look at the internal baffles, we recommend use of a borescope. Those are fairly reasonably priced now. We also recommend carbon monoxide detectors be placed in the aircraft. Some of those are pretty cheap and it's well worth having. Now let's look at some of these accidents related to exhaust and muffler failures. So here's a accident. The pilot and passenger departed from a paved runway on a local flight in an amphibious airplane, and the passengers described the airplane's rate of climb after takeoff as slow, and it was apparent the plane would not clear the 50-foot tall trees ahead, and a definite power loss. Pilot performed a forced landing on a river. Plane immediately nosed over and began filling with water. The landing gear was extended and the water rudders were retracted. The landing gear position indicators were operational and indicated that the landing gear was extended. The position of the landing gear likely resulted in the airplane nosing over on impact with the water. So when they looked at the engine, they found that the muffle baffles had broken at the weld point, and that baffle was rattling around inside the muffler. So it was turned 180 degrees, blocking the exhaust outlet. And the test run of the engine with the mufflers installed was not successful. Here's another one. I pulled this one from the database. This happened in our district. This was in 2023. This Beech C-23 crashed, tore the whole right wing off, substantial damage. Fortunately, there were just minor injuries. So what happened with this one? The pilot experienced wind shear, elected to go around, and had an engine loss of power, forced landing, and collided with fence and trees. That's the NTSB probable cause. Loss of engine power during go-around due to a failed muffler flame tube, which resulted in exhaust blockage. Contributing to the accident was maintenance personnel's inadequate inspection of the exhaust system during the most recent maintenance. So during the accident investigation, they took the borescope and found that the flame tube there was some corrosion, and that's where it broke away. And it was lodged in the tailpipe. On the outside of the muffler end cap, there was a crack. So that's kind of obvious. If you were really looking, you could see that. And you want to look up the exhaust pipe, take a borescope, flashlight, whatever, look up in there. Oftentimes you can see something amiss. So could this have been prevented? Well, back in 2000, the airplane's muffler was repaired and inspected. And it had some pretty extensive repairs. That's what they did to it. 3 tabs, outer shell, 2 caps, 2 flame tubes, 2 elbows, 2 beaded ends, 2 end plates in the tailpipe. And that repair actually did last 23 years. Now, at what point do you replace instead of repair? That might have been a good candidate for replacement, although I can't really say anything derogatory because, it did last quite a while. But that's what our handbook says. We recommend replacement with new or reconditioned components rather than repairing. Now, on that aircraft, the most recent inspection was November 23rd, 2022. The accident was September 23rd of 2023, so almost a year went by, or the annual was within a year. So now, if you do an inspection in accordance with the scope and detail of Part 43, Appendix D, that's what it says about exhausts. Exhaust stacks for cracks, defects, and improper attachment. It tells you what to look at, but doesn't really tell you how or give you any specific details. Always consult the aircraft maintenance manual, doing an inspection and repair. The manufacturer knows their product best. And so on this beach, the maintenance manual for the exhaust system, they would like to have it overhauled or replaced every 800 hours or when the condition warrants replacement. And then they tell you at each 100 or annual inspection, all exhaust muffler shrouds should be removed and the muffler thoroughly inspected for cracks, leaks, and if applicable, deterioration of the internal tubes, which could cause a decrease in engine power due to blockage of the exhaust. So the manufacturer always gives you the best information. And then in the actual service instructions, they tell you how to go about doing the pressure test. 15 psi G and immerse it in water or paint it with a soap solution. So one of our San Antonio District IA sent this one, and this was off a beach bonanza. And you can see the flame cone supposed to be centered, not sagging like it's shown here. And he says this is easy to inspect just by looking up the exhaust pipes. Here is a fatal accident of a Varga. This was up in Bowling Green, Ohio, doing a VFR cross-country flight after he purchased the airplane. Flew about an hour and 20 minutes, and the aircraft suddenly entered a spiraling descent from cruise flight. Witnesses observed the plane flying erratically at a low altitude before it impacted an open field. And they stated the engine was running until impact. And you can see the crack in the heat exchanger. The most recent annual inspection on that airplane was completed less than a month before the accident. There shows the cracks in the heat exchanger, and the toxicology test of the pilot showed that he did have carbon monoxide poisoning, probably unconscious when the crash occurred. And that was the NTSB probable cause, carbon monoxide, loss of control due to impairment from carbon monoxide poisoning. Contributing factor was the corrosion on the heat exchanger and failure of maintenance personnel to adequately inspect and repair or replace the exchanger during the most recent annual inspection. Here's another one that happened down here, Round Rock, Texas. This was 2020. This was a Cessna 320, and it was also a fatal. This was a multi-engine Cessna 320, departed and proceeded east. The aircraft turned north and impacted trees about 30 miles west of the last flight track data. Post-impact fire ensued and the wreckage was destroyed. A witness driving near the accident site said the airplane flew low and she thought the aircraft would land. Another witness driving near the accident site observed the aircraft flying erratically with flames emitting from the left engine. Didn't remember seeing any smoke in the sky from the plane. Another witness said the aircraft was sputtering and popping as it flew over his home. So it came down through trees, highly fragmented, and was consumed by fire. Both propellers had indications that were consistent with a low amount of rotational energy. So they found that the crash itself was caused by failure of the right magneto on the left engine, and the pilot didn't manage that properly, and so lost control. But then post-examination of the engines showed that both exhaust systems were unairworthy. And you can see the pictures there. They went through many inspections with, obviously, mechanics were missing this for many years. The metal was very thin. There were holes, cracks, and oxidation, degradation. Here's one, a Pipistrel motor glider. Pilot landed and was able to get out before fire erupted. And this was in 2018 near West Palm Beach, Florida. Now, according to the pilot, after dropping off a passenger from a previous flight, he restarted the engine and taxied out to runway 27R. After checking his instrument gauges, he made his radio call, indicating that he would remain in the traffic pattern. And then during takeoff, he noticed the engine sounded a little rough. As he turned downwind, he started to smell smoke. He shut down the engine and returned for landing. Landing was uneventful, but he noticed flames below the right door when the aircraft stopped. So after he exited the airplane, the fire grew and eventually consumed the entire aircraft as seen in this picture. Now, after the accident, they found there was this fatigue cracking that initiated on the inner surface near the circumferential weld and propagated to the outer surface. That was sent into the NTSB, and they do all their analysis, and that's what they determined. The other thing to watch out for, in addition to cracks, are those lugs on the exhaust manifold. Look for missing loose nuts, corrosion, and studs that are missing or loose. Here's another one. This was an experimental amateur built on floats. And this was day VFR. They were going to fly over a proposed hunting site. This must have been up in Alaska, and then return. And about 90 minutes later, multiple witnesses saw the airplane complete two low-level, high-speed 360-degree right turns over a residential neighborhood. Witnesses said the airplane's first 360 turn was accomplished at 150 to 200 feet above ground level. And then the second turn was much lower. So witnesses reported that as the aircraft completed its second turn, the nose pitched down and it went into the ground at a rapid descent. So what they found on this one, the pilot was obviously killed from that one. And toxicology tests showed carbon monoxide poisoning. And here's a crack around the circumference of the exhaust, which allowed carbon monoxide to enter the cabin. Here's another one, a T-206 up in Idaho Falls in 2015. This one, in its initial climb out of Idaho Falls, there was an in-flight fire. The pilot miraculously was able to return to the airport and land. And on this one, you can see the separated tailpipe on the left picture. See damage to the battery and the battery box. And that was just like the proverbial blowtorch. Here's a picture of the outside of the, right near the firewall where the burn through occurred, and then all that smoke and everything went right into the cabin air inlet. Battery cables, melting wire, that insulation is also toxic. NTSB probable cause, in-flight fire during initial climb due to the separation of the engine's turbocharger, wastegate, overboard, exhaust tailpipe. Contributing to the accident was the owner's decision to not comply with the service bulletin that addressed the tailpipe separation. Couple questions I have are, was the owner aware of the service bulletin? And was the mechanic aware of the service bulletin? Person doing the annual inspections. Here's a copy of the part of the cover of that service bulletin. It's to install a lanyard to hold that in place, safety link. They found no lanyard in the airplane and no record in the maintenance logbook that indicated this service bulletin had been complied with. And this bulletin was issued 16 years before the accident, so it went unaccomplished for 16 years. And here's just a close-up picture of, looks like a pretty simple service bulletin. Probably would have prevented this accident. The historical record's kind of interesting. The accident occurred in 2015. The last inspection was 45 hours earlier, and 6 months earlier, the tailpipe separated and caused damage to those battery cables. And that would have been a good time to do that service bulletin. That was the red flag going up. That was the warning. Now, the service bulletin affected 111 airplanes, and Cessna said they sold 91 of those kits. So 20 owners opted not to do the service bulletin. And we all know service bulletins are not mandatory, but many times they are a great idea. And I should say they are mandatory if they are incorporated by an airworthiness directive. And that's kind of what this one was, this slide is telling us, strongly encouraged to comply with. Well, I had another IA from our district send this one in. This is, he says this is a downpipe. It was rubbing on another structure. So you can see the chafing and rubbing there caused that. Another picture from one of our local IAs. It's from an 0200 on a Cessna 150. The aircraft was flying like this. Look at all the discoloration on the cylinder and the crack. Here's a Cessna 150 exhaust. He removed it to get it repaired, but then the whole end fell off. And when he looked inside, here's what he found. Pretty bad. Now I had another IA send me this one, and this exhaust was removed, not for repair. Well, I think for some repair, but probably to facilitate some other maintenance. But it was removed from a 1943 Taylor craft, and he looked into it, and this exhaust was built and installed as an owner-produced part back in 1995. So, and it was still in good condition. So I'd say that's a real good owner-produced part, still going 29 years later. And here is the owner's letter to that company, Aircraft Exhaust Systems, giving them the specifications for the design, building, and testing of the exhaust system. And I just blew the letter up so you can kind of see the details that he provided to them. If you ever need to do this, just take a picture of this slide. This slide and the next slide kind of give you an idea of how to do this. And he even states in his last paragraph, manufacture the part in accordance with 4313A and B. Upon receipt of the part, I will inspect the part to be certain it was made according to my instructions. And he even reiterates, please understand that you will be participating with me in an owner-produced part in harmony with FAR 21303B2, because you will be making the part under my control as to the design, manufacture, and quality control. He did say that this worn stud was also found, and he would replace that. And there was some corrosion on the tailpipe that would need repair or replacement. This is an R44 Robinson 44 system, and one of my IAs sent this in, and they do this particular IA works at a company that does a lot of Robinson work. And his notes here say this is an R44 exhaust collector, obvious thermal fatigue and failure here. The air in this collector is upwards of 1200 degrees Fahrenheit. This can cause damage to adjacent components or even a fire. Very common with the R44 and must be checked closely all the time. Yeah, that one looks like it's going to need replacement. He sent this one as well. R44 muffler with cooling heater outlet blocked off. The muffler in the R44 is used as a heat exchanger for cabin heat, as with many other types of aircraft, but uniquely to the R44, the primary purpose of the airflow of the muffler is to cool it. When the heater is not in use, the air is dumped overboard by use of a slider valve. Having the muffler shroud outlet covered will not allow the muffler to cool properly, causing high engine bay temperatures and accelerated wear on the muffler and engine components. So in conclusion, knowledge is the key to the maintenance of exhaust systems. So make sure you have the appropriate service information and knowledge. I gave you those references, and that is a really good course that we have on FAAsafety.gov. Make sure you do your inspections thoroughly and closely, because you think about critical systems on aircraft, you think about flight controls primarily as being very critical among other systems. And you might not really think of exhaust systems as being that critical, but they certainly are, especially due to the possibility of an in-flight fire or carbon monoxide poisoning. And kind of like landing gear, they are in a very bad environment with high heat and vibration, and the heating and cooling cycles as well. So inspect closely. When in doubt, get a second opinion. The owner and the pilot is relying on you if you're a mechanic. Remember the danger of fire and or carbon monoxide if not maintained, and I highly recommend picking up a carbon monoxide detector. We are increasing awareness of the safety management systems, SMS, that's coming to general aviation, and those are the 4 pillars: safety policy, safety risk management, safety assurance, and safety promotion. If you want more information, there's the link and the QR code. And SMS is mandatory for Part 121 and Part 135.10 or more. And it's going to be mandatory for I believe, for Part 145 and some other types of operations. And what else do we have? If you have any questions, there's my email. Take a picture of that slide. If you have any questions, I will make sure you get an answer. And you will get credit for wings or AMT/IA for this. Give me a day or couple days, probably next week, I'll make sure everybody gets issued the credit. And do a quick look here. Yeah, some of these are pretty extensive questions, so I'm going to have to do a little digging probably to get good answers on these and make sure I get you a good answer. So make sure you get training, so you'll have peace of mind. We have a lot of technical training on our FAAsafety.gov. And I do appreciate everybody for attending. Looks like we had 270 some odd participants, so that's a really good turnout. And I urge you to take what you learned here today. And if you didn't learn anything, just take the awareness itself back to your shops and your communities and share this information. It certainly can save lives if we do better maintenance on aircraft exhaust systems. Thank you for attending. I'm going to stop the recording so I don't forget.